Launch Director.
Launch vehicle is ready to launch.
We have ignition.
You have permission to
2,
launch.
1, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute, and we have an indication of spacecraft separation.
Good morning. I'm Noah Curry, a structural engineer at ULA, and your host for today's Atlas V SBIRS GEO 6 launch for the United States Space Force Space Systems Command. I'm joining you from ULA's Atlas Spaceflight Operations Center here at Cape Canaveral Space Force Station in Florida. Liftoff is scheduled for 6:29 a.m. Eastern, though we do have a 40-minute window available today. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. The count is currently in a 30-minute planned hold. We have 2 planned holds in our 7.5-hour launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues, and we are proceeding towards an on-time liftoff. In addition to seeing liftoff, today's show includes some interesting extras. We'll hear from Mission Director John Steinmeier and learn more about Lockheed Martin's role in the SBIRS program. We'll also recognize a special anniversary happening later this summer. Before we continue, let's check in on today's weather. The Space Launch Delta 45 forecast for this morning's launch is looking good. Let's take a look at the numbers. The probability of violating constraints is currently 20%. Ground winds are 5 knots out of the south, and the temperature is 80 degrees Fahrenheit. The primary concern for launch is the cumulus cloud rule. ULA is launching SBIRS GEO 6 for the Space Force's Space Systems Command. Let's learn more from SBIRS Risk and Requirements Lead, Lieutenant Gregory Skaggy.
The SBIRS GEO 6 LM2100 bus was built by Lockheed Martin, and this provides a flexible, versatile, and scalable common spacecraft bus that enables greater efficiency and resiliency across the space enterprise. The payload on GEO 6 was built by Northrop Grumman, and this will provide sensor data that allows the U.S. military to detect missile launches, support ballistic missile defense, expand technical intelligence gathering, and bolster situational awareness on the battlefield, all features which allow leaders to make decisions and take actions faster to save lives. This satellite is equipped with powerful scanning and staring surveillance sensors to protect our nation 24/7. These infrared sensors detect the heat generated by missile engine exhaust to detect launches and begin the early warning process for civilian leadership and battlefield commanders. The success of this mission and the strength of our deterrence posture is made possible through the hard work and dedication of our diverse and integrated government and industry teams. This launch reflects the importance of partnerships to ensure our nation's security today and for the future.
For today's launch, ULA is using an Atlas V 421 rocket. This is the 95th Atlas V launch and ULA's 152nd launch. Let's learn more about this vehicle, which has been used to launch so many critical payloads to space.
Built in ULA's 1.6 million square foot production facility in Decatur, Alabama, the Atlas V rocket, once fully stacked, stands 194 feet and weighs nearly 1 million pounds fully fueled. At the base is the Atlas V Common Core Booster, which is powered in flight by an NPO Energomash RD-180 engine. For additional thrust at liftoff, Northrop Grumman's solid rocket boosters, or SRBs, are attached to the rocket. Atop the booster is the ULA Centaur second stage, powered by an Aerojet Rocketdyne RL-10 engine. The spacecraft is encapsulated inside a protective 2-piece payload fairing produced by ULA in Harlingen, Texas. With production complete, the booster and Centaur travel from Alabama to Cape Canaveral on ULA's rocket ship. Once in Florida, a series of events lead to today's countdown. The process begins by lifting the 107-foot booster onto the Mobile Launch Platform, or MLP. Next, we made the SRBs. Then, the Centaur's second stage is transported to the pad and lifted into position. Lastly, the payload fairing, with the spacecraft encapsulated inside, is lifted and mated to the Atlas V rocket. Once fully assembled, The launch countdown begins by moving the rocket from the Vertical Integration Facility, or VIF, to the launch pad. To complete this move, which spans about 1/3 of a mile, the rocket is transported by the MLP. Weighing in at approximately 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities lines. Throughout the 20-minute trip, rail cars lead the move, with the payload van providing spacecraft communication and the ground van providing support for the rocket. At the rear of the convoy is an environmental control system, which provides air conditioning to the payload and the rocket. Trackmobiles power the nearly 3 million pound convoy. With the rocket on the pad, the launch team then transitions to fueling and other final preparations.
Atlas V will deliver SBIRS GEO 6 to a highly optimized geosynchronous transfer orbit. Once in space, it will join the previous 5 ULA launched satellites. Let's learn more about today's flight.
Generating a combined liftoff thrust of 1.5 million pounds, the RD-180 engine and 2 solid rocket boosters ignite to start ULA's Atlas V rocket on its trip to orbit. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the rocket experiences during flight. Then, Atlas V reaches Mach 1, the speed of sound. Within the next 2 minutes of first stage flight, the Atlas V rocket will more than triple its velocity following jettison of the 2 GEM 63 solid rocket boosters. Fighting against the force of gravity, the nearly 1 million pound rocket depletes the majority of its propellant. The main engine then shuts down, followed by release of the booster stage. The rocket now weighs a little more than 7% of what it did at liftoff. To deliver SBIRS GEO 6 to orbit, Centaur will perform 3 engine burns. Fueled by liquid hydrogen and liquid oxygen, the first burn takes the spacecraft orbital, reaching a LEO parking orbit. Then, once the rocket has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. After the first main engine cutoff, Centaur coasts around to the destination argument, or celestial longitude. The second burn then kicks the trajectory onto a geosynchronous transfer orbit with a maximum altitude in the geo belt. Following a multi-hour coast, Centaur comes alive for a final burn as it prepares to release the SBIRS spacecraft into a highly customized, enhanced, high-energy GTO orbit. Nearing end of mission, Centaur executes a guidance-commanded shutdown to complete the final burn, a capability which ensures precise orbit injection. More than 3 hours after liftoff, Centaur releases the 6th SBIRS GEO satellite for the United States Space Force, providing early missile warning detection.
In addition to logos representing ULA and the U.S. Space Force, along with the American flag, on today's Atlas V, you can see mission artwork provided by the Space Force. The rocket also includes dedications for 2 ULA teammates who are no longer with us. Let's learn more.
The SBIRS GEO 6 artwork on today's Atlas V 4-meter payload fairing features an eagle, the mascot for the SBIRS constellation, grasping a missile in its talons to represent the detection capabilities of this satellite. On the missile, we see the words Semper Vigilans, Latin for always vigilant. To the right, beneath 3 white stars, a tribute to heritage SBIRS missions, we see red beams signifying infrared rays watching over Earth. Additionally, today's flight is dedicated in memory of Dan Boyd and Jesse Marquez. Dan Boyd started his career with Martin Marietta in 1984 as a missile mechanic on the Defense Systems program. Dan transitioned to the Titan IV program and eventually the Atlas program as a quality inspector with Lockheed Martin. With the formation of ULA, he joined the engines group and enabled the successful execution of the RL-10 program and was critical to the BE-4 engine development plan. Throughout his career, Dan's expertise and skills were continually relied upon, especially in his natural aptitude for leadership and mentorship. He had a sincere passion for sharing his knowledge and was quick to make friends and share adventures with anyone willing to try something new. For many, Dan fundamentally impacted ULA's culture for the better. Jesse Marquez joined ULA's Harlingen, Texas team in 1990 as a quality inspector, where he worked on Atlas I and Titan Centaur structures. Later, he worked in the Gauge Lab as a technician before becoming a production leader in 2002. Jesse led teams in the assembly of Atlas V forward adapters, 4-meter payload fairings, and aft transition structures. From the paint shop to the foam and cork shops to final assembly in the special clean area, he managed many major workstations in the factory. Jesse took immense pride in his work, and his teammates respected his passionate leadership style.
One unique aspect of the Atlas V 4-meter payload fairing halves is that, due to the ridges on the outside of the shells, the mission logo is hand-painted in the ULA factory in Harlingen, Texas. Let's take a look at that activity, which occurred earlier this year. We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Ron McKee will poll the launch team for the final go to pick up the count. 29 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Ron McKee performs the final polling.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
S-gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC verified T0 set for 10:29 to
Verified.
Polling is complete. The ULA launch team and the Space Force mission director are go for launch. From T-minus 4 minutes until launch, you will be listening to Ron McKee and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur, and arming the flight termination system. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go SBIRS. This is the final status check of Atlas, Centaur, and SBIRS GEO readiness. At T-minus 3 seconds, the main engine ignites. followed by ignition of the solid rocket boosters. Then, after seeing Atlas V lift off the launch pad, you'll begin hearing flight commentator Jesse Gonzalez providing launch vehicle ascent data.
Roger. All steps complete prior to terminal count.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
4 minutes and counting. 3, 2, 1, mark. 355.
Ground pyros enabled.
The countdown clock has resumed and we are go for launch at 6:29 a.m. Eastern. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps taking place.
Three minutes.
Securing LO2 topping.
Atlas tanks the flight pressure.
250. FPS internal. One 159. 157. Vehicle internal. 155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120. OCU's arm.
SCS count started.
110.
Vent valves locked.
T-minus 1 minute.
Rock report range status.
Range green.
Forty seconds.
Stable at step 3.
28. 25.
Status check.
Go Atlas. Go Centaur.
Go SBIRS.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the Atlas V rocket for United Launch Alliance, carrying SBIRS GEO 6 for the United States Space Force.
Passing 30 seconds on flight. Vehicle is now 2 miles in altitude. And the RD-180 is now throttling down as expected. Engine response looks good. And the vehicle has completed its roll maneuver. Passing 50 seconds in flight. Mach 1. Atlas V is now supersonic. Vehicle is now passing through max Q, maximum dynamic pressure. The RD-180 is now throttling back up as expected. Engine response looks good. Standing by for SRB burnout.
You are hearing the voice of Jesse Gonzalez providing launch vehicle ascent data.
Coming up on 90 seconds into flight. And we have burnout on both SRBs. And the RD-180 is now throttling back up as expected. Vehicle is now 20 miles in altitude, traveling at 3,000 miles per hour. And we have indication of jettison of both SRBs. And the vehicle has gone to closed loop guidance. And the RCS system is now pressurizing to flight levels. And the reaction control system pressures have reached operational levels. The vehicle is now 45 miles in altitude, about 100 miles downrange, traveling at 6,500 miles per hour. And the RD-180 is now throttling to maintain a constant 5G acceleration limit. Engine response looks good. And the Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. And the RD-180 is now throttling to maintain a 4.6G acceleration limit until BECO. And we have BECO, booster engine cutoff. And we have stage separation. Seeing good pre-start on the RL-10. Standing by for MES-1. And we have MES-1. And we have good indication of payload fairing jettison. This first burn will
This
be
is
about
Atlas
8.5
Mission
minutes.
Control at T+5 minutes. We just heard flight commentator Jesse Gonzalez confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in about 8 minutes. SBIRS provides in-space missile warning. Let's learn more about the importance of this capability from the Space Systems Command.
Our adversaries across the globe, our near-peer competitors, consider the fact that they're being watched and we can see every single launch and attribute it to that actor. That absolutely impacts whether they're going to use a missile against the US or our allies. This is the last SBIRS in the constellation. There have been 5 GEO satellites that have been launched so far, and this is the 6th of them, and that will complete the run for all of the SBIRS GEO assets. SBIRS is on orbit right now. It is performing the missile warning mission. It's a 12-year design life satellite, and the constellation is very healthy and consists of not only the Defense Support Program satellites, but also the space-based infrared satellites.
We often refer to these systems as no-fail, in that they have to be able to detect a missile launch anywhere on the Earth 24/7, but also be able to accurately report that back to senior decision makers and warfighters so that they can make some of the most important decisions imaginable. What gets me going, what makes me excited about missile warning is how consequential and challenging this mission set is. I come to work every day knowing that what I do has a direct impact on our nation's security.
This is Atlas Mission Control at T+6 minutes and 52 seconds. While we wait for main engine cutoff, here is more about the Lockheed Martin built SBIRS satellite. Mission Director John Steinmeier recently shared a little more about the importance of today's flight. Let's have a look.
At Space Systems Command, we are laser focused on the many types of threats in the space domain that threaten to disrupt the U.S. and our daily way of life. Our near-peer competitors continue to develop missile technology that is faster burning, dimmer, and harder to detect. This makes it critical now more than ever to focus our efforts on launch and ensuring each national security space launch is successful to enable delivery of this capability on orbit. This will be the 6th SBIRS GEO satellite we have launched on board an Atlas V. This mission will provide tremendous capability for the defense of our nation and allies and represents thousands of hours of concerted effort by the teams who have made this capability a reality. As you're well aware, United Launch Alliance's Atlas V has a tremendous history of mission success. This will be the 95th flight of the Atlas V and ULA's 95th National Security Space Mission. For SBIRS GEO 6, we will be using the Atlas V 421 configuration. The 421 uses a 4-meter extended metallic payload fairing, 2 GEM 63 solid rocket boosters, and an RL-10 C11 upper stage engine. This mission has been optimized to impart maximum delta V to the space vehicle using an optimized 3-burn injection profile. SBIRS satellites are the first line of defense. They provide timely, reliable, and accurate missile warning, infrared surveillance information to the President, Secretary of Defense, combatant commanders, and the intelligence community, and other key decision makers. The SBIRS system enhances our global missile launch detection capability supports the nation's ballistic missile defense system, expands the country's technical intelligence gathering capacity, and bolsters domain awareness for warfighters on the battlefield. As the last satellite to join the SBIRS constellation, the launch of SBIRS GEO 6 marks the end of the SBIRS development program, but this system will integrate with the next generation of missile warning satellites that are already in production. I'm privileged to be the mission director for the SBIRS GEO 6 mission, and I'm extremely proud of the accomplishments of the integrated team and all the suppliers and partners who have worked diligently to get us to this point. Go Atlas V, go SBIRS GEO 6, and Semper Supra.
In honor of the U.S. Air Force's 75th anniversary in September, ULA collaborated with the U.S. Space Force to form a Human 75 next to the SBIRS GEO 6 launch vehicle. These Space Systems Command airmen and guardians hail from multiple units across the country who are critical to our nation's assured access to space and space sensing mission areas. We're looking at time-lapse video taken yesterday at the launch pad.
And coming up on 12 minutes into flight, approximately a minute remaining in the first burn. Still seeing good performance out of the RL-10 and the RCS system. The loop and bottle temperatures have converged on nominal values. And vehicle remains down the center of the range track.
This is Atlas Mission Control at T plus 12 minutes and 18 seconds. We are now approaching the end of the first burn of the Centaur second stage. Let's listen in as we approach this next event.
Standing by for MECO in about 10 seconds. And we have MECO main engine cutoff. And the RCS system has started 100% settling.
This is Atlas Mission Control at T plus 13 minutes and 15 seconds. Jesse Gonzalez just reported successful completion of the first of 3 Centaur engine burns. SBIRS GEO 6 is scheduled to separate from ULA's Centaur upper stage into a geosynchronous transfer orbit in about 2 hours and 45 minutes. At this point, we'll close our live coverage. I'd like to thank Jesse Gonzalez for his participation in today's show. You can stay updated on today's long ascent with ULA's live blog at ulalaunch.com, or join the conversation on Twitter and Facebook. I'm Noah Curry. Thank you for joining us this morning. Before we sign off, let's take another look at liftoff, which occurred at 6:29 a.m. Eastern. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of the Atlas V rocket for United Launch Alliance, carrying SBIRS GEO 6 for the United States Space Force.